Hello and welcome back. In today's video we are going to study frameworks of studying mechanics of matter, we can say. So two famous frameworks that we use to study mechanics of matter means mechanics of solids and mechanics of fluids, is Lagrangian and Eulerian frameworks. So this today's video is devoted to these two frameworks. So let us start. So first of all, what does it mean to be frameworks for studying mechanics? For example, from class 9th we have studied solids. And how do we study it? We have a solid and it has some initial position and it has some initial velocity, and what we do is we choose frame of reference, and related to this frame of reference we know what is its initial position, and as it moves with some velocity we keep track of its motion, we keep track of its positions. Suppose after some time its new position vector is r, it comes here. So what we do is we analyze this particle, this body at different location with respect to some frame of reference, and we keep track of its two things. We keep track of its velocity and we keep track of its position. We keep track of its velocity, we keep track of its position, and these are the two things that we need to have full information about this particle or this body moving individually. Because suppose for practical purpose we would want to know what is energy, that is 1/2 mv square. So if we know v, we know that energy, and when we know this velocity, when we know it is position at every instant, which means we know it is path of motion. So path of motion and velocity are the two things that we need to know everything about its motion, or to extract any information, to use it for any practical purpose. We need these two information, and this is how we study it. We use a frame of reference, we track its position and we track its velocity at different instants of time to get this path of motion and velocity. Now this framework of studying motion is known as Lagrangian framework, in which we track individual particles with respect to some frame of reference to get its path of motion, to get its velocity, because these two will give us everything about that body in order to use it for practical purposes, to build anything out of it, to create anything out of it. Now here is the question. So this is Lagrangian. So we have been studying Lagrangian mechanics since class 8th, 9th. We have extensively studied it in class 11th. So we studied in Newtonian mechanics a lot. So that was unknowingly Lagrangian framework that we have been using. Now here is a question. For example, if we have a fluid, not a particle or a solid, it's flowing, how can we use Lagrangian framework? We'll say, okay, same concept, choose a frame of reference, and track particle's motion at every instant to get path of motion and velocity. But this fluid is made of millions of billions of particles. To track individual particles motion is not practical, it's not possible, it's very, very difficult to do in this Lagrangian frame. So we need different framework to study this type of mechanics, or the mechanics of this fluid flow in this case. So the question comes, if we cannot track these track the particles motion individually because there are millions or billions of particles, how do we study it? Because that will become impossible in this frame of reference, in this framework. So how do we study this? Now we have to know that if this is suppose a wind turbine and air is flowing over, this is the fluid flowing over. So we do not, in this case, what we are interested in, how much rotational power is obtained, W dot rotation obtained, so that we can relate it to, say, electrical power obtained and all that. So are we really interested in the motion of individual particles striking the blades, or studying, or it is enough to study the bulk motion, the motion of all the particles taken together when they together strike the blades and rotate it? So these are two concepts. One, studying the how individual particles strike the blades, and another is how the bulk fluid together strikes the blades and get the same rotation. So since we will get the same results when bulk fluid strikes, when we study this fluid, taking it as a bulk, striking the blades, making it to rotate, to get this rotational power and convert it into electrical power, we will get all the practical jobs done by considering it as a bulk, as a fluid, as a body moving, or as a cluster of particles that are moving in bulk. We'll get all that information from this, so we do not need to track particles individually, these billions of particles individually. That's not important here. So what we'll do is we enclose this turbine in a region. It can be of any shape, of any size, but we try to make it as simple as possible, because analysis will be highly dependent on the complication of the analysis, will be highly dependent on how simple the control surface we have chosen. We have to make it as simple as possible, means we have to try to make it as regular shaped and as normal to velocity as possible. That will make analysis possible, otherwise the outcome will be same. This will just simplify the analysis. So we'll consider this region in space and say the velocity is striking this boundary, this side boundary at right angle, and leaving this boundary at right angle, and the air is coming. We're not interested in the individual particles. The fluid is coming with some set of initial properties and is leaving with some set of final properties. We'll do final minus initial properties in any, like temperature difference, the pressure difference, velocity difference. We'll get the change in property. Then we relate this change in property with the process happening inside to relate it to the let us say rotational work obtained, or rotation obtained, or electrical power obtained, all that. Now this way of studying mechanics is known as using Eulerian framework. Now this looks similar to control volume concept, because the concept of control volume came from the concept of Eulerian framework or Eulerian study of mechanics. So in Eulerian framework, we do not need to track particles individually like Lagrangian framework. What we are interested in, the bulk motion of all the particles together, how they affect the process in bulk, not individually. This is known as Eulerian framework. Now there's an important question. For example, solid mechanics we study in two ways. One is rigid body mechanics, and another is called deformable body. Deformable body. And rigid body mechanics, like the mechanics we study in high school, a body particle is moving at some velocity, what will be the kinetic energy and all that, forces are acting, we apply Newton's law that in the body is moving. But deformable body mechanics is in which we study stress, strains and all that. That's also studied using a Lagrangian framework. But one may think, for example, this is a beam supported at two ends like this. And there are also, like fluid, there are also millions, billions of particles. So shouldn't we this study using Eulerian framework rather than using Lagrangian framework? So the answer is no, we don't need that. We can study it using Lagrangian framework, but that requires tracking individual particles. Yes, we track individual particles. We locate or we specify only critical points on the beam, say the center point or a point near here or a point here. We only track the specific particles. Suppose we choose frame of reference. Suppose this is frame of reference that we choose, and with respect to this frame of reference, when this beam is bent, when this beam is deflected, like this, we track the motion of these critical points, how much this gets deflected, gets displaced during this deflection, how much this point gets deflected during this, gets displaced during this deflection, and how much this point gets displaced during this deflection. Because these are the critical pointers, and based on these critical pointers, we will find the stress and strain at these locations, and we'll make a criterion, or we'll be having formulas which will tell us when this displacement exceeds or this stress strain exceeds this particular value at these critical locations, it will fail and all that. So this looks like millions of particles needs to be tracked, but we only track critical points on the beam or any other body in deformable body mechanics, and study it using Lagrangian framework. We have a frame of reference, and we track these critical pointers only. So all this is studied using Lagrangian framework of mechanics, studying mechanics. Now, all of this forces us to think that Lagrangian framework or Lagrangian way of studying mechanics is restricted to solids, and Eulerian framework is restricted to fluids. It looks like that, and when we study books, and it also looks like that, but this is not specifically specific to solids, and Eulerian framework is not specific to liquids or fluids. I will give an example in both, in which Lagrangian is applicable, is the only way to apply in fluid case, and the Eulerian is only applicable in case of solids. For example, let's take example of solids first. Now there are kind of solids which are called granular solids. Granular solids. Granular solid is a solid which is itself is a system of solid which is itself made of small particles of solids, and they move together as a system. So basically they are solids and they move together as a system. We call it a granular solid. And we use Eulerian framework to study its motion. A practical example, in pharmaceutical company, when tablets are produced, and we need to coat them with some chemicals. For example, how do we do? For example, we have a spherical chamber in which these tablets are placed together. So this becomes a granular solid, and this chamber is rotated, and we have sprays of these. We have sprays that spray this chemical to coat these tablets, and it rotates as well while we spray. So what happens is we are not interested in where each tablet goes, but we are interested in the bulk motion of all the tablets together, so that the coating happens uniformly on all the tablets. So this is a granular solid, but we are not interested in the motion, in tracking the motion of individual tablet, but we are interested in the bulk motion. We want to rotate everything or this all the particles in this circular fashion, so the coating happens uniformly at the uniform velocity, rotational velocity, so that coating happens uniformly. So this is an example of solid, but studied under Eulerian framework, in which, like fluids, no individual tracking is done, but bulk motion is studied. So here also bulk motion is studied, so we use Eulerian framework. So this is an example. So Lagrangian or Eulerian framework is not restricted to fluids only. Now another example in which Lagrangian is not only restricted to solids. Now for example, we have diesel engine. So what happens is air enters this engine, and on the other hand we spray fuel. So these are fuel particles. Now if we consider the fuel particles only, the fuel enters, it gets atomized, atomization occurs, which means the fuel gets divided into smaller droplets. After the atomization happens, each fuel droplet absorbs the heat from the air. It gets vaporized, it vaporizes, and it uniformly mixes with the air. Now here, when we talk about these fluid particles, we are interested in individual fluid droplet, because it's important that we track each and every particle so that uniform mixing happens. So we track everything using obviously computers, not naked eye and all that. We track these particles should go this way, that way, that way, in all possible directions, so that uniform mixing happens between fuel and the air. So what we do is we track individual particles trajectory where they are going for uniform, because if the fuel plus air mix is not uniform, the efficient combustion will not happen. We will see from the exhaust chamber, from the exhaust supply system, and that exhaust system, that the smoke that comes out is basically partially burnt air fuel mixture, or incompletely burnt air fuel mixture, or unburnt air fuel mixture, which will reduce the fuel combustion efficiency and which will reduce the mileage as well. So we are very, very much interested in tracking the path, tracking the motion of individual fuel droplets inside the engine using the computer, using the aid of the computers and all that, and simulations and all that. So this is an example of fluid not studied using Eulerian framework, but due to individual tracking of the fuel droplets, we use Lagrangian framework. So these are two frameworks that we use to study mechanics, whether solid mechanics, rigid or deformable, or fluid mechanics, whether compressible or incompressible and all that. And I give an example that Lagrangian is not restricted to solids and Eulerian framework is not restricted to fluids. So we have everything to start studying, analyzing fluid problems, fluid flow problems, because first of all what we have to do is choose what we are studying. That is, we have studied system, so we know whether this has to be studied using system concept or control volume concept, and after that now we know whether we want to track individual particles, then we will use Lagrangian concept, or we are not tracking individual particles but we are interested in bulk fluid motion. That means we are using Eulerian framework. Now in both the frameworks the equation will be different, but the result will be the same. The equation, the formulas, the structure of the formula will be different, but the result will be same. The difference in the formulas is because we are choosing two different frameworks, but using the same basic principles of physics, whether conservation of mass, conservation of energy, conservation of momentum. When they are applied in Lagrangian frame, their formula structure will be of one type. When they are applied in Eulerian frame, their structure will be different because the things will be more complicated. And when we know this is the system, this is the way we to study. That means if it is Lagrangian, we know we have to start with some frame of reference. If it is Eulerian, then we have to start with choosing some region in space. So this is where we know whether we are studying Lagrangian or Eulerian. We start with frame of reference, Lagrangian. We start with choosing control volume, it is Eulerian. So this will be all in this video. Thank you.